Okay, so this is the recording for 11/4. As you're aware, I have dental surgery Saturday, November, whatever last Saturday was. Um, so it's recording. Okay, great. A couple things. I have a lot of pre-developed code for this, but it's all very, very disorganized. We're going to follow a very specific pattern. One, we're going to do some very simple threading. Okay, our initial simple threading model will just create some threads, show you some examples of what a thread looks like. We'll do some really simple detaching, really simple joining, those type of things. But generally simple threads, right? Nothing outrageously complicated. Um, Remember, we aren't really gonna detach that often. But remember, once we detach, we can't um, join again. So we'll talk about that in another way. But again, the next set of threading models will be thread in and output. How do we get threads data into threads? Like, how do we tell a thread, you do this thing and you do this? So we'll do that. We'll do some inputs. We'll pass strings. Um, you'll note because of the pointers, it's not super always, I'm sorry, my phone's going off. It's not always super duper straightforward, but it is very, very doable. I believe I have a lot of broken code on my computer. That's why we have five different directories. Keep in mind, though, this is also five different directories for both days, 11/4 and 11/6. Sorry, my dog's not feeling very well. A little surprising. Um, but anyway, we're going to be doing thread put, input, and out. But we're going to be doing waiting for threads as well. And we'll be doing more complicated than simple joins. So we'll be doing that. And then we'll try to do some um, evidence that threading is not safe, right? Now we're going to show you a bunch of different things, and some of it's going to fail, and you're going to go, "Why is it failing? I don't understand." Um, Pretty simple reasons. We're going to use sleep a lot today, so if you're unfamiliar with that, go look at the process section. Sleep just takes an int number of seconds. Um, we're also going to use random functions as well. Now, actually dealing with threads not being safe with mutual exclusion, we will do that another day. But what we're going to do today is use a variety of techniques designed to um, do some simple threading. So we're going to go ahead and get started. The first set of examples are going to be very contrived. I'm not even trying to do anything complicated here. All I want to do is show you how to create a thread and execute the thread. Um, if this is difficult for you, the rest of it is going to get even worse, and it's going to get worse really quickly. So what we have here is a thread, and it has a thread function, and I believe this is not the simple one. Nope. This is me trying to show you that failure can occur. This is not a simple one. Yep, same thing. This is input and output failing. Not very exciting. This one is exciting. This one we can do, we can use P2 and P3. P1 is more passing, so we don't want to do that. I am going to actually create things in the 114 directory. I'm just going through and seeing where, because there are actual simple code here. It does exist. Um, it does exist. But one of the caveats, yeah, P2 and P3 are definitely the simpler ones. All right, so let's go ahead and create a new file, and we're going to call it p1.c. Um, Interestingly enough, I told a student last week that her code was copied, very similar to someone, or I shouldn't have said her, but very similar to someone else's homework. So I was like, this is very similar to someone else's homework, and it's not even a C file. And the student was very confused. P1.c is a C file. The C compiler does not like random stuff. It won't work if you use something else. And so that is usually a clear giveaway that there's a copy and paste situation going on here. All right, so we have pthread self. Hello, I'm thread. I use LU. It is an unsigned integer, and I'm using the long version of it to get it to print out, get it to look reasonable. Um, Nothing exciting here. We need a TID because we're going to get one. Note this is not an integer. Okay. Now what we're going to do is we're going to create it. Oh yeah, I remember. I'm going to leave this off. I do need to leave that off. And I'm going to sleep for a second. So I'm going to create it and I'm going to sleep for a second so that make sure we have time to actually see this operate, right? Yay. Hmm. So you see after creating thread, it never said, hello, I am thread, okay, at any point. But we have a bigger question, okay? Look at the actual CD here. Yes? This pthread create should not even be running. And you're like, wait, what do you mean? It doesn't use, let's go P1, P1C, right? Because we're not including the pthread, right? So now I can execute P1 and it should execute it. But note, it's saying it created the thread, but it's never doing the actual thread. There's actually a reason for this. I could sleep for 5 seconds and there's a chance that we might see it. So we'll go ahead and run that again. So now it's going to sleep for longer. Still no luck. Okay. Let's go ahead and wait for it via the join. There's your thread. It waited for it, so therefore it's going to run. And then what's called. And so wait, how does it take 5 seconds? So it doesn't, right? Like, and you're like, what do you mean? Well, it's not really. It's that um, sleep is not actually what you think it is for the most part. Sleep is a busy wait. So you got to make these sleeps really long. I mean, really long in order to them to actually do what you think they do. Because you actually have to have the CPU give up its CPU time. And you're like, wait, what? Yeah, the CPU has to give up its wait time. So with short sleeps, it will not give up its wait time. We'll talk about timers later on, but it does not really give up its what's called on short sleep. So you have to do a longer sleep in order to get that to work. But that's not really an effective way to do it. Effective way to do it is the join, and you don't actually sleep at all. Yes. Do do do. Okay, so we're going to run this again. Note, I don't need that second sleep at all. A couple of you may notice that it does in fact sleep and then does it. That's kind of mediocre, right? That doesn't really matter. If I make it a short sleep like this, make it 5, it still may not give up the CPU, by the way. A couple other things is this might, yep, well, it does that time, but it may not give up the CPU quickly enough. It may not. You never know. Which is kind of non-deterministic, right? Which is not great, right? Um, you can't count on those sleeps being equal. Okay. One thing I want to talk about briefly too is while we're doing this is um, yes, okay. So I detach in the next one. Okay. Okay. So all I'm going to do here is instead of joining, I'm going to go pthread detach, right? And you just got to give it your TID, right? I believe that's all I did in P3, right? Oh, wait. Shoot, sorry. I am doing this poorly. Hold on one second. Right. And I want to save this as, I'll just save and it'll pop up the window. I want to save this as p2.c, right? We want to make sure that we are leave all the stuff that we had so that you can play with this later. Okay. P2.c, we're going to go ahead and detach. Now, I'm going to sleep 5 seconds. I don't know. Doesn't really matter because the CPU is not giving up. 5 seconds should do it. My number lock is off. 5 seconds should do it in this case, but usually more than a couple seconds is usually enough too. But you're not guaranteed, right? So now we're detaching it. But what happens if I don't do the sleep, right? Now, this is going to be a little bit harder because we don't have the sleep above, okay? The program exits, and as a result of the exit, even though the thread actually executes, it's detached, but it goes away when the program goes away. So if it doesn't execute for whatever reason, it's a little slower before we get to the here, it's done, right? So there's no waiting on it. That's not how it works, right? And once you detach it, you cannot join it after that. One of the things that really, really need to remember is detaching is not, and I repeat, it is not for situations in which you are actually trying to, um, you know, if you have to wait for it, like, you're doing some work and then you're waiting for all the threads. You gave 6 workers some work to do, and you have to wait for all 6 of them to finish. That's not what detaching's for. Detaching's for situations where you have a long running server and then you detach for the thread so that it just cleans up. So you never have to wait for it. Because that can be very, very bad. Let me just double check a couple more things. Yeah. We went over basic thread creation. That's what this is. Nothing exotic here. Boom. All right, now let's do inputs. So what we're going to do here, and we haven't done here, is right now the thread actually has no input, right? So how do we send input to a thread? How do we identify you do one, you do two, you do three? The other thing too, and I think students really appreciate this. I don't know if they do or not. I'm guessing here. Um, but a lot of students want to see multiple threads being created. So let's go ahead and do that real quick. That's p3.c that we're creating. And so all we're going to do is I'm going to create 3 of these, right? For ints I equals 0, I less than 3. All right, so I am getting a little ahead of myself. I apologize. That was what I was doing wrong. Um, Boom. Yes. Now I'm going to try to implement a sleep. Now what I'm going to do is I'm going to sleep 5 seconds. Hopefully we have 3 to print out, right? Probably not 3 that are going to print out, right? You'll see this in a second. It does for this case, right? But you're not guaranteed. Do, do, do. I'm hoping we'll see a case where we only have 2 printed out. It might actually be rare with the 5-second sleep, but all right, maybe if I put it down to 3, we'll see some. Because we're doing a sleep and we're not necessarily waiting for the things to finish, right? But we can see some interleaving happening. Creating thread after creating thread, creating thread after creating thread, creating thread. Hello, I'm thread. And then after creating thread, it goes back to the original. The first 5 of them were very much what's called. So that's kind of interleaving, which is good. But you see the interleaving happens very late. Yes? And in most cases, the thing waits, and then it's the waiting that actually allows the triggering to stop. That's because, don't count on threads to stop immediately. Sometimes they go 4 or 5 lines of code, and if you're doing something simple, there's no reason it won't look like it's interleaving. It can, but it won't. And remember, your computers do have multiple CPUs, so it does and can handle parallelism. Parallelism does occur. All right, let's do something more interesting. Okay. Note these numbers are meaningless. Don't try to calculate them. Don't try to, figure out, oh, I have one thread. I know how to cancel another. That's not how anything works. Don't do that. Oh, let me show you one more thing. I'm sorry. There is a more complicated weight here. I just need to grab this. So how can we do a more complicated weight here? Very, very simple. So I'm just scrolling up. You see this thread ID? What I'm going to do is I'm going to create three of them. Yes. And I'm just going to let them all be zero. Why do anything other than that? And then pthread ID, we're going to pass the I, right? It's still the pointer. You're still passing the pointer. But now you're going to have an I. So now instead of sleeping and hoping we get them, we're going to wait, and then we're going to join. I'm sorry, I'm brain farting here. And we want to do I. Yes. So now it's going to actually wait on each one of them. This is the expectation. And you go, wait a second, that's not super parallel. And you're like, what do you mean not super parallel? Right? You're like, well, it's going to create one, it's going to create the other one. Did I screw something up? Probably did. Hold on. I joined somewhere. Oh, yeah. No. I know why it takes two arguments. I always forget. Oh, yeah. I don't care about status for this. For this point, I don't care about status. Okay. Bang. So now it's joining. Now there's no need to, you're guaranteed you're going to get each one. Now, what if I use my random number here? I think I have to include math. Don't remember where random is, right? Yep, it's math.h, I believe. Yep. Okay. So inside main, we're going to go srand now or null. I think we use time there. Think brain farting. Here we go. So we're going to set srand, and then in our random function, we're going to go rand mod 5. And that, my friends, is how long we're going to sleep. Yes. Now, what we don't have is any way of knowing which one was created ahead of time. So what we're going to do is simply put, we're going to print out the TID. Yes, that's it. So we're going to say, and then how do we print them out before? It was like LU, right? And then we'll come back in here with a comma and we'll go TID at I. Yes. Booyah. Okay. So now we know which order they're going to be created. They're going to print themselves out. Great. And then they're going to wait in the order in which they were created. That's how we did it. Okay. But now at least we have some sort of tracking. Yay. So 400 was created first. And we can see that 696, which was actually created second, actually wins. And then 992, the third one, finishes third. Yay. They do actually are, in fact, waiting. They are, in fact, waiting for them in order. So we're cleaning up the resources for the first one. We're cleaning up the resources for the second one. We're cleaning, right? So they are going to be 400 in that order. And that's just how it goes. We're going to talk about ways in which we can alleviate the ordering We can, some threads might take longer. Might take shorter amount of time. So we'll talk about how we can do that later, not right now. Um, we're also going to need to at some point, um, not now. We're going to talk about the max number of threads. I think we're going to do that today or tomorrow. I'm not sure which day that is, but there is a max number of threads. You're going to have about 30,000 threads on a machine, usually somewhere in that range. And what that ultimately means is that once you create threads beyond that threshold, it's telling you it's creating threads, but it may not, and you're losing all the work that's associated with whatever it was trying to do, which is very, very bad. So we'll talk about how we can create a certain number of threads, and then keep those threads alive, so to speak. When a thread finishes, we create a new thread, as opposed to um, just creating an endless number of threads, right? It's a really bad idea to do that. And there are easier ways to do that too, but we're not going to deal with that today. All right, let's pass information to threads. That's what we're going to do next. And what that means is we're going to see where we're creating a thread and we're not actually passing anything. What we're going to do immediately now is we're going to actually have, we're going to pass two things. Obviously, a number is very, very vital. So we do need to know how to pass numbers. The second thing we want to learn how to pass are, in fact, I'm sorry, my nose. The second thing we're going to try to pass is string. Strings are very, very important for, a lot of system administration type tasks. So we want to make sure we're doing that. Okay. So let's go ahead and create a new file down here, and we're going to be p5.c, and we're just going to stick with the basic p1. Okay. And you go, wait, what? Yep. The thing we started off with is going to go in p5. Okay. Because we need to actually pass in the arg. Okay. Now, if you remember, that's going to go here. Okay. But how do we actually pass it? If you look at other examples, you can see I get a pointer. I'm actually passing pointers, right? Yes. Yes. So I'm usually passing a pointer. Okay. Now, this one's bad because it's a string, so we don't really care about that. Um, but we are in fact passing a pointer. So how do we deal with that, right? But we'll talk about that in more detail. We do need to pass a pointer. And this is where it gets a little hazy. So some of the code is very incorrect. Um, here I'm using a string because the ints weren't working, I believe. Mm-hmm. That's status. We don't care about that. Counter, don't care about that. All right. Where's the code for this? This is where we run into so much fun. And this is just passing a pointer to a character. Mm-hmm. I mean, I guess I can just make it up as I go along. That's what I do a lot of time. But does seem like a stupid way to go here. I used characters before. I don't know why I'm not using them now. All right, let's do it to it though. All right, so what we want to do here is to pass an arg. And so instead of null here, we're going to pass an arg. Pretty simple. So obviously I want to pass a number, right? Int number equals 3. Why not? Okay. And so what I'm going to do here is I'm going to get a pointer, num here, and I'm going to get the address. I don't know why I can't seem to find it. Address of number, right? Pretty simple. And then I'm just going to pass num here. Okay. That is one half the ball game. Watch, I'm actually going to compile it to make sure it compiles. Okay. Ta-da. Okay. I'm not screwing around. I'm just literally creating it so that I can get the thread. Look at that. I'm just creating the thread. The reason why we want to do that is we really want to make sure equals, right? And you're, wait, what are you doing? I'm actually casting the arg to be a pointer. I never get this right. So I'm just compiling it to make sure I'm right. Thread, do. I'm gonna get rid of sleep too. Print F. My number was D, I think. And then do. I'm gonna get rid of that actually. I'm not gonna print that anymore. My number was D and boom. Yes, I believe I have that right. I don't know if I do or not. Yep, it compiles. Yay! Nope. Oh, that is a dot instead of a comma. Why is it compiling? Have you noticed everything's compiling no matter how bad it is? Yes? All right, let's get rid of the sleep and put the join back and get rid of your sleep. Okay. All right, this is where we get a little hazy. Oh, because usually I have examples. So, yay. So I got the wrong pointer. And you're like, wait, what? I got the wrong pointer. Okay. Or did I? Nope, I got a pointer. Yes. I'm setting the pointer to be an integer arg. And I think what I'm screwing up here, and let me just double check it. Because I do have an example somewhere of a string. Yes, the character S, same thing, except it would be a 100% sure this didn't work, but those are character strings, not, as you can see, I'm passing in character strings, not numbers. This is the one I'm looking for. This is the one I'm eventually going to create, but something's probably wrong here. Nope, there you go. So they finished with return code 0. One of them failed, as you can see here. Okay, none of that matters. Um, just gonna grab that. That's what we're looking for. Num int num arg, got it. Then it prints out a bunch of numbers. Nobody cares. Okay. Am I passing it weird? That's your caveat. That must be what's wrong here. P1 bot C. Huh. I am passing it differently. Oh, I think I do. Okay. So let me grab this. Okay. Okay. I think I see what's wrong, but I don't sure, so I want to write it down. Okay. Okay. So what I did here was I got the pointer, right? I got the pointer to number. I don't want that. You know what I want to do instead? No, why don't I just leave it as number? So grab number. Put it here. And I want to cast it as, okay. And I think that was where this was going wrong. Oh, wait, what am I doing? In function main, coin capacity of different size. Okay, it's a warning. So I don't know how to get rid of the warning. I'm sorry. That I don't know how to do. Um, that I do not know how to do. I'm sorry. Like that, I don't know how to get rid of the warning. Um, but you can see it's creating thread after thread. The number was three. I can change this number to anything I want. All right. Why did this work without the warning? It's also an integer. There is no cast to an integer of different size. That is weird. I don't know. That is weird. I will look into this, but it is in fact doing what it's supposed to be doing. So actually, you know what? It's been a half an hour in. I can take a break here, and I'll come back and I'll see how why that warning's occurring. But a key thing is it is actually doing what it's supposed to be doing. So I'm not overly worried about it, but it is a good time to break. I could use a 5-second breather anyway. Thank you guys. I'll come right back.